Welcome to Study Loop.
Okay, so we're given some data. Presumably, this is an acid-base titration in which we were adding base to neutralize acid, right? Meaning we had a very acidic solution in terms of pH. Put that backwards, pH, okay? And as we were adding milliliters of sodium hydroxide solution, right, at some point, we reached what's known as the equivalence point. And that's where we had added enough base to completely neutralize our acid, right? So the equivalence point is when our solution reaches pH 7, basically, right? So what we're told is that around 3.5, right, we had added 16.6 mils, okay? And that eventually we got up to like 9 or something, and that at that point we had gotten to 17.4, right, mils. But that somewhere in between these two was the equivalence point. Okay. And that's what we're looking for, is this point here. Right. And so we can calculate when this would be, right? If we assume that things are linear from here to here, we can calculate that. How do we do that? Well, we find rise over run, right? So the data points we have around that are 17.4 minus 16.6, right? This is the amount of, sorry, this is backwards. We want to look at the pH. We want rise over run, that's y over x, right? So we do y2 minus y1 over x2 minus x1. And we'll find the slope of that line, okay? So what is the slope of that line? It is going to be 9.44 minus 3.5. Those are the y values, right? That's the pH and the pH there. Okay, and then the x value is going to be the difference here, right? So that's 17.4 minus 16.6. Okay, and then these are pH units and these are mils. Okay. And what do we get? Let's calculate this. 9.44 minus 3.5 divided by, in parentheses, 17.4 minus 16.6. And I get 7.425. Okay. And then if we put this in point slope form, or say like y equals mx plus b, right? And we can figure out what b is, right? So if we take any old data point, so it could be 17.4 equals, and then slope, that's 7.425, 7.425 times x. So x would be the data point that matches that. Oh, I'm backwards again. This needs to be 9.44. 9.44, that's our y value. And our x value is 17.4 plus b, and we need to solve for b. Okay, so b equals 9.44 minus 7.425 times 17.4. What do we get? 9.44 minus 7.425 times 17.4, and we get negative 119.755. Negative 119.755. Okay, so that's B. So then our equation is y equals 7.425 times x, right? That's milliliters. So we're saying pH. This is milliliters, okay? And then we subtract 119.755. And the equivalence point when the pH equals 7, right? So we're saying we want to know what x is at that point. So we say 7 equals 7.425 times x minus 119.755. And then we just need to solve for x, right? Let me move this over. I'll blow it up. Probably see it better. Okay. And then we're just going to do a little bit of algebra and solve for x. So we say 7 plus 119.755, all divided by 7.425. What do we get? 7 plus 119.755 in parentheses divided by 7.425. I get 17.07. 17.07, and that is in milliliters, right? Which means that when we were at pH 7, we had added 17.07 milliliters. Okay, and then the significance of this 17.07 is that acid concentration equaled the base concentration.